So the carbonyl compounds, what are the carbonyl groups? When we have C double bonded with O and H, or we have C double bonded with O and surrounded by the carbon chain, we call them as a carbonyl groups. When the C double bonded with O and H, we call them as aldehyde. And whereas the carbon chain is surrounded, like C double bonded with O, is surrounded by the carbon chain, we call them as a ketones. And we have discussed how we can form these aldehyde or the ketone. If we have a primary alcohol, the primary alcohol will be oxidized to aldehyde. A partial oxidation result in a formation of an aldehyde. But if we have a secondary alcohol, the oxidation of the secondary alcohol result in a formation of a ketone. And if a aldehyde is further oxidized, it will turn into carboxylic acid. That's how we can form these compounds. So the compound which are having C double bonded with O group, we call them as aldehyde or ketone. Like here you can see we have two carbon atoms. So because of the two carbon atoms, we call eth. Eth is the prefix used for the two carbon atoms. They have a single bond between them. When they have a single bond between them, we call N, eth N. Due to the presence of C double bonded with O and H, what we call is an aldehyde, or the name should end at L. So it will be ethanol or ethanol. What if we have a C double bonded with O group is surrounded by the carbon chain? It's a ketone and the name should end at ONE. There are three carbon atoms. So we called prop because of the three carbon atoms. They have a single bond between them. So we called N. And remember, whenever the functional group it's having a wall, in that case, we remove the E. And then we all call on. When, like example, if it is a symmetrical ketone, we don't number that. If it is not symmetrical, example, it's always propane 2 on. So we don't have to number. When it is the carbonyl group, the C double bonded the O group is present at the center. But what if we were having CH3, C double bonded with O, CH2, and then CH3? In that case, we have to position the carbonyl group as well. If I position from the right hand side, it will be 3. But if I position from the left hand side, it will be 2. So second position, we have a carbonyl group. So we call but because of 4 carbon. They have N because of a single bond between the carbon structure. And second position, we have ketone or carbonyl group. So we call butane 2 on. So when it is a symmetry, like if I count from here 1, 2, 3 or 1, 2, 3, it does not make difference. That's why when there's a symmetry, the carbonyl group surrounded by the carbon chain and equal number of the carbon atoms around it, in that case, we don't have to number. Is it clear? Then the solubility, when we compare the solubility, we have the concept that the like dissolve like. Like if it's an identical group, it will dissolve the identical group. So the like dissolve like. So lower. Yeah, that would be same for 5 carbon atoms as well. When there's a symmetry, like equal number, and usually it has happened when you have an odd number of the carbon atoms, you will have a symmetry. Like let's say we were having CH3, CH2, C double bonded with O, CH2 and CH3. So this is also a symmetry. In that case, I don't have to count the carbon atoms. I will just, because it's a symmetry around left and the right hand side, equal number of the carbon around the carbonyl group. So what I can say but because of 4 carbon, N because they have a single bond, and on because of the ketone or butanon. Instead of saying butane 3 on. If it was other way around, like if it was not but, pent, because of the 5 carbon, I should say pentanone. But what if it was CH3, C double bonded with O, CH2, CH2, and then CH3? In that case, there's not a symmetry. One side, three carbon atoms, and the other side, one. So now we have to number the carbon, and we can number from the right or the left, but we always follow the numbering where it's closer. So five carbon atoms are there. We call pent. They have a single bond N. Now the second carbon is having a carbonyl group. So this is pentan 2 on. So if it is a symmetry, no need to number. If it's not, then you have to number. Now the solubility, like when we compare the intermolecular forces between the carbonyl groups, when we compare the intermolecular forces in the carbonyl group, like if it's an aldehyde or a ketone, so it is C double bonded with O and H is there. And oxygen is having a lone pair. And then there is also a carbon chain around. So R means the carbon chain. And there's C double bonded with O and H is there. So due to the difference in electronegativity, oxygen will be partial negative and carbon will be partial positive. This also partial negative and partial positive. So because they have a permanent dipole, so the attraction between the permanent dipole, that is dipole-dipole force. And due to the presence of the carbon chain or the number of like the electrons, they will also have dipole-induced dipole. But there is no hydrogen bond. Within, like between the two molecules, they don't have a hydrogen bond. Why they don't have hydrogen bond? Because the hydrogen is not directly attached with oxygen. Hydrogen is not directly attached with nitrogen or fluorine. That's why between the two aldehyde or the two ketone molecules, there is no hydrogen bond. But what happens when we add these aldehyde or a ketone into water? So water is H2O, in which hydrogen is bonded with oxygen. Now what will happen? This hydrogen, which will be partial positive and oxygen is partial negative, there will be attraction between the hydrogen of the water molecule and the lone pair of oxygen on the oxygen of the aldehyde or a ketone molecule. They will have a hydrogen bond. So between the two molecules of aldehyde or a ketone, there is no hydrogen bond. But between the water molecule and aldehyde or a water molecule and a ketone, they can form hydrogen bond. That is why the aldehyde or a ketone, which is having a lower carbon number, they can dissolve in water or mix with water. So, but as a number of the carbon increase, like if the chain length increases, if we have more carbon atoms in this chain, then what will happen? The dipole induced dipole forces or the chain, the length of the carbon chain does not allow this hydrogen bond to form easily. That's why the higher aldehyde or ketones are not soluble in water or does not dissolve readily. So smaller carbonyl groups are water soluble, but as the number of the carbon increases, the solubility of these aldehyde and the ketones will decrease. Is it clear? The concept of solubility of aldehyde and ketones? Okay. Now we have the reactions. There are different reactions of aldehyde and the ketones. So the reaction of the carbonyl, because of the difference in electronegativity, carbon is partial positive and the oxygen is partial negative. So the nucleophile can attack on this carbon positive. So usually the reactions of this aldehyde and ketone are nucleophilic addition reaction. The type is addition and the mechanism is nucleophilic. And we'll learn the mechanism. But student taking Cambridge, you have to learn the mechanism. But for Edexcel students, you don't have to learn the mechanism. So if you have a primary alcohol will be oxidized to aldehyde and aldehyde further oxidized to carboxylic acid. If you have a secondary alcohol, it will be oxidized to ketone and tertiary alcohol cannot be oxidized at all. These are also the tests to check the presence of aldehyde in a ketone. If you want to check the presence of aldehyde or a ketone, because aldehyde can be oxidized to carboxylic acid. So if the oxidation happened for aldehyde, the reduction will happen for the other substance. Like this equation, this is ethanol, okay? The ethanol is converted into ethanoic acid. This is ethanoic acid. So this change is oxidation. So what will happen when we have a potassium dichromate or the dichromate ion? This dichromate ion will reduce in a dichromate ion, which is Cr2O7 with a total charge, net charge of 2 minus or minus 2. So each oxygen is minus 2, 7 oxygen will be minus 14. And so what should be the net charge? Because the net is minus 2 or 2 minus, so the two chromium should be plus 12 and each will be plus 6. So in dichromate ion, the chromium oxidation number is plus 6. But when it will form a chromium, the oxidation number is plus 3. So this is orange in color. The original solution is orange in color and this is green in color. So when a oxidizing agent, potassium dichromate, is added to aldehyde, the aldehyde will turn into a carboxylic acid and the dichromate ion will turn into chromium ion with the oxidation number of plus 3. We observe the color change because of change in oxidation number. It changes from orange to green. So if aldehyde is present, then this reaction will occur. But what if we were having a ketone? Because ketones cannot be oxidized. So ketone cannot be oxidized. If we have a ketone like CH3, C double bonded with O and CH3, and we add potassium dichromate Cr2O7. So there is no reaction between them. Why? Because ketone cannot be oxidized. So if the oxidation does not happen, there will be no color change. The chromium remain plus 6, so it will remain orange in color. Is it clear? The change in color for the chromium, for if it's an aldehyde. Why the potassium symbol is not used in the equation? Because this is an ionic equation is written. That's why potassium symbol is not shown here. This is an ionic equation. In ionic equation, we cancel out the spectator ion. Actually, potassium is a spectator ion. There's no oxidation or reduction. That's why the potassium symbol is not used here. There's also another way to identify or check the presence of an aldehyde or a ketone. We can use toluene reagent. So what is a toluene reagent? It contains a silver 1 ion. So when aldehyde is there, if aldehyde is there, aldehyde will be oxidized to carboxylic acid and a silver 1 ion will be reduced to silver atom. As a result, when it form a silver atom, it will form a silver layer. So this is also called a silver mirror test. Like we have a solution which contain an aldehyde, like we don't know whether it's an aldehyde or a ketone. We want to test. So what if it was an aldehyde and we add the toluene reagent, which is aqueous ammonia and the silver nitrate, mainly contains silver ion. So this in the toluene reagent, it contains a silver ion. The silver ion will be reduced to silver atom, and that silver atoms will stick to the wall of the test tube, and this test tube, the wall will have a silver layer. So that's why we also called as a silver mirror test. Like it will be deposited on it will be there at the bottom as well as on the walls. We'll have a silver metal. So it will looks like a layer of a silver. That's why it's also known as a silver mirror test. But if it's a ketone, because a ketone cannot be oxidized, so if it is a ketone, there's no like oxidation for a ketone or reduction of a silver, so there will be no change. So if we were using a ketone here, if we were using a ketone, then this reaction will not proceed, so it will remain as a silver ion or the solution remain colorless initially. There's also a third way. So for students taking EdXL, you don't have to. Why a ketone cannot be oxidized? Because for an oxidation to happen or occur, oxidation is addition of oxygen or removal of hydrogen. So first, what will happen when we have an alcohol? When we have an alcohol, like example CH3, C double bonded, CH3, CH2, and OH. So in a first, when alcohol is oxidized, what will happen? It turn into aldehyde. How it turn into aldehyde? That one of the hydrogen is removed from here and another hydrogen removed from here. So this will become CH3, C, and this one of the hydrogen removed, one is left, and then it will become C double bonded with O. That is how primary alcohol turn into aldehyde. And then aldehyde turn into carboxylic acid. So C double bonded with O. So this first is oxidation. Oxidation is a removal of hydrogen. So first is a removal of hydrogen or addition of oxygen. The second, what will happen? An aldehyde turn into a carboxylic acid. So it will be CH3C. OH is added here, like OH as oxygen is added to hydrogen, and it will be C double bonded with O. So this C double bonded with O and OH, it is a carboxylic acid. So why ketones cannot be oxidized where aldehyde can be? Because the ketone does not have a hydrogen, the carbon, which is having like C double bonded with O and CH3. So there is no hydrogen available. There is no hydrogen here to attach with oxygen. That's why the ketone cannot be oxidized further. But aldehyde can be. Because in an aldehyde, we have C double bonded with O and H. So hydrogen is there. With this hydrogen, oxygen is added. It becomes carboxylic. But here C double bonded with O, so there is no hydrogen attached to this carbon. That's why it cannot be oxidized. So aldehyde can be oxidized, but ketone cannot be oxidized. So for students taking Cambridge, you have to learn the equations as well. But for EdExcel, just the observations, what will happen. Then we have a Fehling or a Fehling solution we can also use. So what is a Fehling solution? It contains a copper 2 ion. Copper 2 ion is blue in color. So same thing if it's an aldehyde, aldehyde will be oxidized to carboxylic acid, and the copper 1 ion will turn into copper 2 ion turn into copper 1 ion and combine with oxygen to form a copper 1 oxide, which is usually red in color. So what we'll observe, originally the solution is blue. Why the solution is blue? Because of the presence of the copper ion. Copper ion makes the solution blue. But when aldehyde, if in the presence of aldehyde, the copper 1 ion, because aldehyde oxidized to carboxylic acid, and the copper 2 ion turned into copper 1 ion reduction. And this copper 1 ion combined with oxygen to form copper 1 oxide, which will form a red precipitate. So if we use a toluene reagent, if there's an aldehyde, we'll observe a silver layer. If it is a Fehling or Benedict solution, what we'll observe? We'll observe that a blue solution turn decolor turn into form a red precipitate. But if with a ketone, there is no reaction happen or occur. Is it clear, these observations? Then if a substance is oxidized, the same way we can also reduce the substance. The reduction reaction of the carbonyl group, it is the opposite. Like if you remember, when we have a primary alcohol will be oxidized to aldehyde, and aldehyde can be oxidized to carboxylic acid. So opposite can be done. Opposite is a reduction reaction. Like carboxylic acid can be reduced to aldehyde and aldehyde to primary alcohol. So because the forward reaction, like when we are converting them, we call them oxidation. So reverse reaction will be the reduction reaction. So these substances can be reduced. So for a reduction, what we use a reagent, which is lithium tetrahydrodualuminate. This is the name of the compound. In a dry ether. So ether is not a reactant here. It is it is the medium in which the reaction can take place. So it's not like a reactant here. It's just a medium in which the reaction can take place. Like if you just recall the idea that when we have halogenoalkane, we use aqueous potassium hydroxide, and we use alcoholic potassium hydroxide. So aqueous and alcoholic, that's a medium, like in the mixture, that providing a solvent to mix with the reactants can mix with each other. So dry ether is not the reactant here. It is the solvent. It is the solvent which allow the substance to mix. So we use a reducing agent such as lithium tetrahydrodualuminate, or we can also use sodium tetrahydroduborate, which will reduce the carbonyl group into alcohols. And if it's an aldehyde, like this, you can see it's an aldehyde. So aldehyde will be reduced to primary alcohol. Reduction means addition of hydrogen or removal of oxygen. So in this case, what will happen? The hydrogen is, you can, like, C double bonded with O and H is there, and the hydrogen is there. It is added to, so oxygen will form a bond with the hydrogen and turn into alcohol. And the carbon, like two hydrogens are there, so one of the hydrogen will form a bond with oxygen, another hydrogen will form a bond with carbon. So it will turn into primary alcohol. So it was C double bonded with O, and an aldehyde was there, C double bonded with O in H, and there was a carbon chain. And reduction means addition of hydrogen or removal of oxygen. So this is addition of hydrogen by using a reducing agent. So one hydrogen attached with oxygen, another hydrogen attached with carbon. So it will become the carbon chain, then C, then oxygen and hydrogen attached with each other. This hydrogen is already there, another hydrogen. So what it will turn into primary alcohol. So whenever you have an aldehyde, the reduction of an aldehyde result in a formation of primary alcohol. But what if it was a ketone? The reduction of a ketone result in a formation of secondary alcohol. Like the same way, C double bonded with O and the carbon chains. No, there's a difference between writing H2 and 2H. This is actually, we are not using hydrogen in the reaction. As we are not using hydrogen in the reaction, we are using a reducing agent. So when the hydrogen is coming from the reducing agent, we call that as a nascent hydrogen. That's why it is written 2H like this. If we were using a hydrogen element as a reactant, then we'll write H2. As you can see from the reagents, there is no hydrogen used here, but still hydrogen is produced. So when the hydrogen is produced during a reaction, we represent by this symbol. It was not used as an original reactant. It is just produced during a reaction by the reducing agent. That's why it is written in this manner. So there's a difference. If for example, if the reagent was hydrogen as well, then I will write as H2. But reagent is not hydrogen used. It is produced during a reaction. That's why it is written 2H, which shows a nascent hydrogen, a hydrogen which is produced during a reaction. So how it will turn into a carboxyl, like the ketone will be reduced. So let's take like two carbon chains are there, and we have a hydrogen from the reducing agent. So one of the hydrogen attached with oxygen, another hydrogen attached with the carbon. So it will be R, C, O, H, H, and R. So what it is turned into, you can clearly see that the carbon attached with the OH, it is surrounded by the two carbon chain. So carbon surrounded by OH group, it is surrounded by two carbon chain. That's why we call it will be a tertiary alcohol. So, sorry, secondary alcohol. Tertiary cannot be oxidized, so it cannot be reduced as well, as it is not forming a product. So primary aldehyde will be reduced to primary alcohol, and ketones will be reduced to secondary alcohols. Is it clear, this one? Yes, hydrogen is still the reactant, but this hydrogen is produced during a reaction we also call a nascent hydrogen. So it's a reactant, but it's not, we don't say hydrogen reactant. We say that this hydrogen is produced by the reducing agent. during a reaction. Any doubt in this? Okay. Then we have a very important reaction mechanism. This is only for student taking Cambridge, not for Edexcel students. You don't have to learn this. And you will learn this, but in A2, not in AS. So, but for student taking Cambridge, you have to learn the mechanism. This is the nucleophilic addition reaction in the aldehydes or the ketone. So example, we have, first I will show journal mechanism. So we have an aldehyde or a ketone. If it is an aldehyde, it will be carbon chain. And if it is a ketone, it will be C double bonded with O and R. So first what will happen? We use a hydrogen cyanide or HCN. Only this topic is only for edX for Cambridge student. After that, there is a topic which is common. Only this mechanism you don't have to learn. No, you don't have to leave the session because this is only a part of the topic which is not with you. The mechanism is not with you. Don't leave the session as I will teach the topic which are common. Only this part. So we have HCN, the hydrogen cyanide. So the carbon is partial positive and oxygen is partial negative. Here also carbon is partial positive and oxygen is partial negative. And in HCN, when we divide this hydrogen and nitrile group, so the hydrogen is partial positive and the CN is partial negative. And same thing, if we have hydrogen nitrile, HCN group, hydrogen cyanide, you can also say, so partial negative and partial positive. So what will happen? It's an addition reaction. Addition, when we say it's an addition reaction, so there is only one product. So what will happen? This H, which is partial positive, the H which is partial positive will be attracted to oxygen, and the CN which is partial negative will be attracted to the carbon. And this is not the mechanism, this is first the product. So it will be carbon chain C, OH will be there, CN will be there, and H. Or it will be R, C. Now the double bond will turn into a single bond with oxygen, hydrogen is attached, and with carbon, CN is attached, and then the carbon chain. So whenever we have one product by two or more reactants, what we call that as an addition reaction. So this is an addition reaction which happen or occur, and this addition is known as a nucleophilic addition reaction. Why we call this as a nucleophilic addition reaction? Because the reaction started by the attack on the positive center or by the nucleophile. This is the overall equation. Now, how the mechanism, how this reaction will proceed? If we have C double bonded with O, and we have like CH3 and H. So what is the bond angle? The bond angle will be 120 degrees. It will be trigonal planar, and the oxygen will be partial negative and the carbon will be partial positive. So we have the CN, because this HCN will break down into what? It will break down into H plus and it will break down into CN minus. So this CN, which is having a negative charge and a lone pair, so this will attack on the positive center, so it will attack on the carbon. It can attack from the bottom, it can attack from the right, it can attack from the left. It does not make difference. Equal possibility because all the bond angles are 100 and like 20. So equal possibilities there. I can draw from right, left, up. Does not make difference. Now what will happen? This oxygen which is more electronegative, so it will take both of the electrons. So when oxygen will take both of the electrons, so we'll have C, CH3, H, This CN group is now attached to the carbon, and the oxygen is also attached, but the oxygen is having a negative charge. Why oxygen is having a negative charge? Because oxygen took both of the electrons, so it become a negative charge. And this oxygen, which is now having a negative charge, will attract, like if we have HCN, so this oxygen which is having a negative charge will attract this hydrogen to form a bond. So when this oxygen will attract this hydrogen to form a bond, the final product will be C, CH3, CN, H, and OH. So, and plus CN group is there. And now this CN group will again attack on another molecule and the reaction will continue. Is it clear? This mechanism of addition reaction, the nucleophilic addition reaction. What is the name of this product? How we name this product? So we have OH is there. No, actually reaction started because of a CN. But how we get the first CN? To get the first CN, we mix potassium cyanide with hydrogen cyanide. The potassium cyanide, which is an ionic compound, it will break down into K plus and Cn minus. So the first reaction, the first Cn is coming from this one, potassium. This is the addition reaction. No, how we got the first Cn? Because as you can see here, this is the first Cn. So from where we get this first Cn? We get this first Cn by using a mixture of potassium cyanide and hydrogen cyanide. When we have a mixture of potassium cyanide and hydrogen cyanide, HCN does not break down. But KCN is an ionic compound which break down into K plus and Cn minus. So this Cn will attack on the carbonyl group, attach with the carbonyl group, and then the HCN molecule loses its hydrogen to oxygen and produce Cn. So this Cn which is produced now will attack on another group. So we will have another group like C double bonded with O and CH and H is there. So this Cn which is produced here will attack on the carbon and then continue. But from where we get the first Cn? The first Cn is actually from the potassium cyanide. That's why if you see the reagent, we use HCN in the presence of KCN. So what is the purpose of KCN? The purpose of the KCN will dissociate into K plus and Cn minus, and then the Cn minus will attack on the partial positive carbon and oxygen take those electrons back. So it will become Cn and then HCN molecule, hydrogen bond with oxygen, so produce another Cn. So there will be another Cn. And that Cn now will attack on another molecule and the reaction will continue. What will be the name of this compound? Because the Cn group is attached, so we select the longest carbon chain. So 1, 2, 3. So second position, we have a methyl group, and second position, we have OH group. So it is what? It is 2-hydroxy. 2-hydroxy, 2-methyl, and 3 carbon atoms are there. So it will be prop, and they have a single bond N. And because of this group, Cn group, what we called nitrile. So it is propan nitrile. Like here, we select the longest carbon chain. So, and this is the main group which affect the chemical properties. That's why the Cn is included here. Or you can include this carbon chain. So 1, 2, 3. So second position OH, second position methyl. So second position, we have OH group, second position methyl. That's why we call 2-hydroxy, 2-methyl, 3 carbon atoms. So we call prop, single bond between them N. And because of this CN group, we call nitrile. So this will become 2-hydroxy, 2-propyl, 2-methyl nitrile. Same thing happen if we were having a ketone. The reaction mechanism does not change. It's remains the same irrespective of aldehyde or a ketone. So we have C double bonded with O, CH3 and CH3. It's a trigonal planar. So we have partial positive, partial negative. And the first CN is actually produced because from KCN. So it will attack on the partial positive carbon and the oxygen will take both the electrons, which result in a formation of CO negative charges there. We have CH3, and then CN group is attached. Then the HCN molecule, this oxygen will try to form a bond with hydrogen and the CN will take both of these electrons. So this will become OH, CH3, CN, and then CH3. Plus CN is there. And this CN which is produced, again it will attack on another molecule and the reaction will continue. How to name this compound? We select like we have COH is there, and then CH3 is there, CN is there, CH3 is there, and CH3. So we select the longest carbon chain. We have 2-hydroxy and 2-methyl. Because when we name the branches, we name them in alphabetical order. And then 3 carbon atoms are there. So we call prop, single bond N. And because of the CN group, we call them as nitrile. So it is 2-hydroxy, 2-methyl propane nitrile. Is it clear? The mechanism, and we call that as mechanism is a nucleophilic and the type is addition. Okay. In exam, if they ask what is a mechanism, it's a nucleophilic mechanism and the type of a reaction is addition reaction. Any doubt in this?